Thank you very, very much. Thank you, Lior. Thank you for having me today. So I will just start by saying that this discussion or the next 30 minutes will focus on things that are also security driven. I see that my video is stuck. Apologies for that in advance. But what I wanted to talk with you all about today, or maybe beforehand, Leo, I don't think that my mouse is working, or it can't.
Yes, give us a sec.
Okay, I need to give it a second. Okay, so just like 10 seconds about myself. 20 years or so in cybersecurity. Today, I'm leading product security and the engineering group that is actually developing cybersecurity microservices into the FICO platform. Most of you might not know FICO, but FICO is the company that does the credit scoring for a lot of, so all of Americans, a lot of the European countries, and also does a lot of things in the data management and data decision management world. So essentially a data analytics company. On side notes, previously the CISO for Botec, as Lior said, the cybersecurity CTO for MDocs. Today, generally investing in early stage startups, mentoring and advising startups, aside from my day job in FICO. And the topic I chose to talk to you about today is observability and observability from the security side of things. So I don't know if you heard about that buzzword, observability, but we all, as security experts being in the market, we have all, learned and grew up on the fact that logs are a significant part of our ability to detect and respond to cybersecurity attacks as they occur. Of course, with the evolution, with big data analytics and such, we've got more predictability, the ability to create anomaly detection and more behavioral analytics. But at the end of the day, logs have been a fundamental part of cybersecurity or information security for many, many, many different years. Observability is not a new thing. It has been here for quite some time, but essentially it is an encapsulation of logs, which is one of the things that are encompassing observability, but also traces and logs, and metrics. So today when you're thinking about observability, you want to understand how an application is functioning. How the application is functioning is not just, did the user log in, I ran some report, those are the log side of things. It is also the duration they took, what is the performance of the server or the services or the containers that are running the service itself. And essentially observability is the encapsulation of everything, being able to provide organizations like FICO where I'm working today, the ability to actually learn, understand how the environment is functioning, how it is operating, if there is a need to deploy more services or auto scale. And of course, as a sideline thing, but a very important thing for our discussion today, is the environment secure? Are we seeing any behaviors that we haven't anticipated? Are we seeing any type of attacks on our environments? So essentially, the bottom line is if you're thinking about observability, in order to reach observability, you need to monitor different application outputs. That includes metrics, traces, and logs. And with this, I will jump back to observability in just a couple of slides. But I wanted to talk about one of the big changes that are happening today in the software world in general. And I do assume that every person on this call that has been or is working for a company that develops some software have heard the name or have heard about microservices. And the reason it is important to talk about microservices and talk about how applications were built 10 years ago, 5 years ago, even today in some cases, and how microservices and modern applications are being built, is that if you're thinking historically, you wanted to log an application. Let's say that I have an application that processes invoices. If I wanted to log what is happening in the system and understand if the application is under attack, if a customer is under attack, I had everything under the same roof. I had the same development manager, the same development lead. I had the same engineering team, I had the same operations team. So it was very easy to come and say, guys, these are the things that we want you to write in the logs. These are the things that we're expecting to get. And you had a single owner and one application stack that actually wrote everything, right? So from start to end, from the point that an invoice got into the system up to the point that the application finished processing the invoice, it was one event. It was one event from one system. Nonetheless, today, when we're thinking about modern applications, it is significantly different. The idea in modern applications is that instead of creating a very, very big component that will do everything under one roof, you start developing much, much smaller components. Every component has a different responsibility and a different piece that when you're binding it all together, it provides you that oversight and that holistic transactional view that you need. But if we're taking it to, as an example, logging, that means that if in the past it was one event log saying a file was uploaded to the system and we scanned it and this is the result for the invoice handling, today you have many different microservices. So a business transaction can be built from, again, anywhere between 1 and 10,000 and even more services. I can tell you that in FICO, we have hundreds of services. So a single transaction can touch many different services. And literally, when you're thinking about a service, it is an application at the end of the day. And because of the way that it is being built, you cannot really build a meaningful event out of just one service. So it's not like one service owner can build the entire subset of things we need in order to understand what is happening in our system. Another point of congestion, or another thing that makes things even harder, although of course it is much better from both a design and architecture and a software point of view, is statelessness. So if you're thinking about services in the past, it was a service per customer, a service per owner, just like you would have installed it on premise. Today, when you're thinking about SaaS companies, as an example, they don't really care who is the customer, right? When you're going and logging into Gmail, it is not that Gmail has a specific instance for your mail address. It is a single system with many different users. And if I'm taking it to a more enterprise world, if you are using Salesforce as an example, you are not really using an instance that is completely dedicated of Salesforce for your usage. It is shared. That means that the front end is being shared between multiple customers. It means that there are other processing services that are shared between multiple customers. And that means that a service might not even know who is serving. So think about converting currency. If I needed to convert currency from Israeli shekel to US dollars, does it really matter who is the customer I am serving? Probably not. All I need to know is what is the sum of money I want to convert, and let's say which date it is, because currency changes, of course, but that is pretty much it. So how can I really still know that that currency activity is bound to a single customer? And how can I actually know that an entire life cycle is associated with one transaction? And that is a very big challenge in today's modern applications. When you are starting to scale, it is becoming increasingly hard to really understand what is happening in your system. And this is where essentially observability comes into play. This is where the observability world comes into play. So first of all, a little bit about the high level glossary for observability. So a metric is essentially a data point. It can be a simple 1 digit or 2 digits or an integer that represents how much time it took to run an action. It doesn't have anything. It might have just the identification of what action it is and just the duration, as small as possible, in order to deliver that in hyperscale, which again, think about billions of transactions per minute or per day. You need to be able to rationalize the data in a fast way. The second term is a span. So a span is a single operation that is being logged. A span can be one specific metric, okay, from one specific system. A trace is a group of spans. So when you're thinking about how will I actually know, and let me annotate on the screen. Okay, I don't know if you can see my mouse now, but essentially when you're flowing through the processing, how can you actually bind a span from the file transfer to a span from the OCR microservice to a span from the ETL? All of those will be bound under what we call a trace. And then we have a log or a log record, which is the traditional security notion that we understand, which is the timestamp, what happened, who, what, when, where, how, etc. All of this, by the way, it is important to mention, the glossary is based out of OpenTelemetry. OpenTelemetry is the de facto standard in the market for observability. It is open source, but it is supported by companies like Google and others, so it is very well founded. So when you're thinking about spans versus traces, as I mentioned, there are spans being created for each and every one of the microservices, and then you have a trace for all of them. Now, at this point, I will actually start jumping into the security part of things, because up until right now, nothing is about security. And the point about security is that we have a very big problem. In security, it was easy for us in the past. We collected log from an application. We collected an event, an event, right? It said, at this point in time, user Naor generated a report, and this is the report, and it succeeded, and everything is great. Today, in order to construct that simple event, it can mean I need to aggregate data from 50 different services. And that is essentially substantially different from what we were used to do in the past. So again, examples to that, a currency conversion service may convert currency, but it doesn't really know who it is converting to. A business transaction can be 15 different services. Some services might fail. So in our rationale as security people, we always have success and fail, right? But if you have 20 services in a line, right, and only one of them have failed, does it mean that everything failed, or does it mean that it was a successful thing? So those are the sort of questions that we need to start asking ourselves as security people, because usually we care about the failures just even more than we care about the successes, right? In the time of the event, again, it is broken down. So I have a timestamp from many different services. It's not just one timestamp. So how do I actually know when something happened, when it is a rolling activity? So who is not known across the board? What can be a lot of different things? When and where are single points, and success and failure is ambiguous. That is the biggest challenge that we have found when we started working on observability. In fact, from a security standpoint, when you're starting to build microservices and scale microservices, it is becoming immensely hard to actually identify what is happening in your systems and being able to do the right security tracking and auditing. And this is where Cornerstone comes into play. I will say, before jumping into Cornerstone, which is, by the way, a project that will be very soon open sourced, and everyone are encouraged to go in, read the spec, contribute back, that would be great. It will be, again, completely open source. It's not something that we have done to keep internally. But I want to provide some context. So what we're trying to do, what we need to do as security people, what we need to do today in a modern application is that we need to start collecting data from many small services, being able to bind them together and then reconstruct them into a meaningful event. So I think that the keyword, and I will repeat that in a lot of times in the upcoming couple of minutes, meaningfulness of the event. An event that is not meaningful is useless for security. If you have the, I don't know, let's say a user failed to authenticate 10 times and then he succeeded, but you don't know the username, that event is meaningless, right? You can't do anything with the data. And for us in security, the meaning is the most important piece. That is why we always talk about the who, what, when, where. That is pretty much what's building the meaningfulness of events. So essentially, when we're thinking about modern applications, the meaningfulness can only come into play when you are aggregating a lot of small data points into a larger scope that actually defines how the application is behaving, how the greater transaction or how the transaction the customer is expecting to have is actually happening. So what is Cornerstone? Cornerstone at the end of the day is a unified and expandable specification of events that enables product teams, developers to create a consistent and unified view structure for events across the board. So when you have one application, and I some of you that might have done SIEM projects, SIEM projects, when you need to integrate a new data source, you are starting to reverse engineer the structure, you are building a data point, right? And then you can start ingesting it, building rules, etc. The problem with microservices is that if you have 100 of them and everyone is building their own structure, then you need to reverse engineer 100 times the structure of the event. And it is not guaranteed that all of the events will have everything you need. So essentially, Cornerstone started from, we want to be the de facto standard to how events are being built in an application. It doesn't matter if it's a monolith, if it is a microservice, it is just a way to enable everyone to talk in the same language. The big difference between that and what some of you might know as Splunk Common Information Model, Elastic has their own, the people that have been in the industry for longer, ArcSight CEF, Common Event Format, is something that is well known. The difference between Cornerstone and those is that Cornerstone does not just define what are the fields. It also defines the relationship between them, what is needed, so what is mandatory, what is optional, what is conditionally needed from the product teams, and when teams are starting to adopt it. Actually, what we are doing is that we are abstracting all of that SIEM integration into Cornerstone. So think about product teams building events in a way that you don't need to think about. You can just onboard it automatically without even thinking, how am I breaking down my event into a SIEM ecosystem? So essentially, that is Cornerstone in general, and a little bit into how it is built. So first, the ground rules. Cornerstone does not define what events the team should log, right? The what is still driven by the business logic. If the company is a retail company, the what will be different than a data science company, than a financial company, than a security company that builds missiles or such. The what is different based on the business use case. So that is the first thing. Cornerstone doesn't define what. It defines the how events will be logged, which is, it does not define how the events will be logged. Event will be continuously logged as they were in the past. So if you are using, as an example, Fluent D or a Splunk heavy forwarder or any sort of log aggregator, essentially you can still use the same shipping mechanism. It is not changing that fundamental. What it does define is the structure of the event, or how the event is built, from the basic fields, who, what, when, where, to the more extended ecosystem, who initiated it, what was the impact. The second fundamental is that Cornerstone is contextual. So the most important piece, and one of the things that are missed the most, is that context. So think about a framework that provides you that core event structure, exactly what needs to be in that, and then you have contextual logic. If you have data associated with the event, then you can add the data context and break it down into smaller contexts, such as information context, database context, and I will touch that in a second. The user context. So if there is a user involved with the event, you can add the user context into that event. All of those are conditionally added into the core event. So you can always have the very, very smallest amount of data you need in order to make the event meaningful. However, you can always extend that based on the business needs and based on the security needs. And the third important piece, regarding the structure, And this is just a high-level view of the architecture itself. I will not actually touch that right now because we will need a few hours to actually review the architecture. I will say that Cornerstone is built to be an addition or a plugin that is working with different tools like Fluentd, like FluentBeat, like Splunk Heavy Forwarder. It is not necessarily replacing it, which is an important piece. However, it does provide some conditional logic for consumers, because one of the things is the security team wants to get some of the logs. The operational team wants to get some of the metrics. One of your customers wants to get only the subset of data associated with that specific customer. All of those can actually run and coexist inside the Cornerstone collector. However, I see that, never mind, apologies. The example of how the Cornerstone event structure is built. So this is actually an event, this is a core event. So this is the very, very basic. You will see on the side mandatory, optional, and conditional. I will talk about that in a second. But essentially what it provides a single way of describing the event. And think about all of the product teams. And again, the more companies move into microservices, the more companies move into larger development organizations, that consistency and persistency will become immensely harder. But you have a single pane of glass and you have a single way of writing those events, meaning everyone can read each other's events in a very easy and consistent way. So this is actually an example of a change password that has failed. It failed due to the fact that the password does not adhere to the password policy. But you can see here the event ID, you can see the environment ID, and you can see some of them are actually optional. So event signature is not mandatory. The deployment environment is not mandatory. However, environment ID is conditional, and I will talk about what is conditional in a second. And then you will see the things that are important for security, as an example, as mandatory, the type, the subtype. This is an example of the user context. Let's assume that we had an initiating user. So who was the user that initiated the event? If we have a data import, what was the data import? What did it include, etc. Of course, it goes into virus scanning, etc. All of those sort of things. And then the usage logic, which is what I wanted to touch on earlier. The usage logic is very interesting. So instead of coming and saying everything is mandatory, everything is optional, you choose whatever you'd like, essentially there is a rule-based system and a rule and a logic system within Cornerstone that enables teams to understand what do they need to do. An example to that can be if multi-tenant is true, if it is a multi-tenant service, then you must provide the customer UUID, and it is still optional to provide the environment UUID. So essentially you have different field types and different field requirements, and that is what drives Cornerstone to be a very easy to implement mechanism. I want to keep some time for questions, so I will jump real quick. If all of the microservices are talking in the same language, and I will say it up front, Cornerstone is not just built for microservices. Every architect in this room that wants to talk to his product team and tell them, here's how we want to receive the logging, it will work the exact same way. It just has a lot more values in microservices. When you have a unified framework, you can have unified logic, you can have better root cause analysis, better detection uniformity, and better product support. And an example to that is this outlook that will be shared again as a part of that open source project. When everything is built in the same way, when you have the same event structure built across the board, what you can do is that you can, in your SIEM system, describe events once and describe the fields that are required for those events, and then already associate all of the rules and all of the widgets and all of the dashboards into that. So think about the product team coming to security. What do we need to log? No issues at all. We expect you log the user authentication event, and here are all of the input fields that are required. We are expecting to see all of the privileged authentication events, and this is what we're expecting to see. So when you're thinking about Cornerstone, think about building your security rules in your SIEM system once and let it be applicable to all of the applications that are being developed by the product teams. That is the outlook for the future of Cornerstone. One last point about Cornerstone regarding metrics and observability. The idea with Cornerstone is that by adding each and every one of the code snippets within the collector, we are actually aggregating and creating one meaningful event, even though it ran through 10 or 20 different microservices, which is what security expects to get. Security expects to get what is the business activity that took place, exactly what needs to be done, and that is what Cornerstone delivers. Again, first, happy to talk about Cornerstone further. We are definitely looking for peer reviews, and in general, it will be open sourced and everyone will be able to use it. Thank you very much. And if there are any questions, I'd be happy to answer.
Okay, guys, if you have any questions to know, please write them down in the chat. So we have one question from Kobe Levy. I know, how do you know the origin of a specific action in a multiple microservice architecture?
Yeah, that's a great question, Kobe. So the idea when you're using traces and spans, essentially so when you're using traces and spans, you're essentially also have a transaction ID that is bound to every event. The idea and the way that we have implemented it is that every microservice, unless he sees in the payload, in the request, unless he sees that transaction ID, he is generating a transaction ID. So the trace and spans, first of all, are one of the things that aggregate everything. And then there is another part, which is the transaction ID. And that transaction ID is actually created by the first initiator of the chain of activities. And every service is validating whether that transaction ID exists or not, or the trace ID, depending on the implementation. If they exist, it does not recreate them, it just adds another span. If they don't exist, then it creates that new one.
Okay. Okay, I hope that's answered the questions. We have another question. How do you know to connect an event in an async process?
Yes. Yeah, again, a great question. When you're using PubSub or any other technologies that might be, that are not synchronous, the way that we have implemented it is that inside the payload, we save the transaction ID or the trace ID so that it is still moving forward down the path. And when the Cornerstone collector picks up on that, it is essentially aggregating the data based on that field ID. So even if you're writing to a Kafka topic, as an example, one of the fields you will be writing is a trace ID, so that when something picks up on that message, it continues dumping spans into that transaction ID. It does create an interesting use case where you might have, two span IDs that are coming at the same time because two services collected from the same Kafka topic. But at the end of the day, this is how it's being implemented. I hope that it makes sense.
Okay, thank you very much, Naor. Very interesting. And as Naor said, he will publish all the code in Git or somewhere, so you can, of course, consume his project and add and contribute to his project. So very good initiative. Thank you very much, Naor. Very insightful lecture. Thank you very much.